The main shaping processes in the traditional ceramics are the slip casting, the plastic forming methods, the semi-dry pressing, and the dry pressing. In the slip casting, a suspension of the ceramic powder in water, called the slip, is poured into a porous plaster of Paris mold. The water from the mix is absorbed into the plaster to form a firm layer of the clay at the mold surface. The slip composition is 25 to 40% water. Principal variations are the drain casting, where the mold is going to be inverted to drain the excess slip after the semi-solid layer has formed, and the solid casting, where the adequate time allowed for the entire body to become firm. In the plastic forming, the standard mixture must have a plastic consistency. The compositions is going to have 15% to 25% water. There's a variety of the manual and machinized methods. The manual methods use the clay with more water because it's more easily formed, while the machinized methods generally use a clay with less water, so starting clay is stiffer. The plastic forming methods include the hand modeling, the jiggering, the plastic pressing, and the extrusion. Hand modeling is fabrication of the ceramic products by manipulating the plastic clay into desired geometry. The hand molding is a mold or form is used to define the portions of the part geometry. While the hand throwing on the potter wheel first is a round table that rotates on a vertical spindle. The product of the circular cross section can be formed by throwing and shaping the clay, sometimes using a mold to provide the internal shapes. In the jiggering process, the wetted clay slug is placed on the convex mold. Next, it's need to have a patting, and the jigger tool is imparts the final product shape. The plastic pressing is a forming process in which the plastic clay slug is pressed between the upper and lower molds. The molds are made of porous material, so when vacuum is drawn on the backs of the mold house, the moisture is removed from the clay. The mold sections are then opened using a positive air pressure to prevent the sticking of the part in the mold. The advantages is the higher production rates than the jiggering and not limited to a radially symmetrical parts. The extrusion is a compression of the clay through a die orifice to produce the long sections of a uniform cross section, which are then going to be cut to a required piece length. The equipment utilized as screw-type actions assists in the mixing of the clay and pushing through the die opening. The products, including the hollow bricks, the shaped tiles, the drain pipes, tubes, and insulators. Also, it's used to make the standing slugs for the jiggering and the plastic pressing. The printing is a forming process in which the pre-mixed plastic clay fed through a nozzle, mainly by extrusions, to add the layers, then build up the part final geometry. Sometimes the chemical binders used instead of water. Thus, it can be classified as a new ceramic processing. The 3D printing enables the ceramic geometries that could not be fabricated through the traditional injection molding techniques. The semi-dry pressing process, using a powder with a water content of a starting mix, is between 10 to 15%. The dies made of the hardened tool steel. Sequence of the process. Start with first, deposit the moist powder into a die cavity. Then press at high pressure. And finally, open the die sections and eject the parts. The dry pressing process sequence similar to the semi-dry pressing, except that the water contents of the started mix is less than 5%. The dies are made of the hardened tool steel or cemented carbide to reduce the wear due to the abrasive dry clay. No drying or shrinkage occurs because the drying time is eliminated and the good accuracy is achieved in the final product. The products include the bathroom tile, the electrical insulators, the refractory bricks, and other simple geometries. The water plays an important role in most of the traditional ceramic shaping processes. Thereafter, it has no purposes and must be removed from the clay piece before the firing. The shrinkage is the problem during the drying because the water contributes a volume to the piece, and the volume is going to be reduced when the water is removed. The drying process occurs in two stages. Stage 1, when the drying rate is going to be rapid as the water evaporates from the surface into the surrounding air and interior water migrates by the capillary action to the surface to replace it. And this is when the volumetric shrinkage occurs. Stage number 2, when the moisture content has been reduced to where the ceramic grains are going to be in contact. In this stage, little or no further volumetric shrinkage may occur. The typical drying rate curve and associated volume reduction for the ceramic body is illustrated in the following diagram. Drying rate in the second stage is depicted as a straight line. It is sometimes concave or convex. Firing is a heat treatment process to sinter the ceramic material. It's performed in a furnace called the kiln. The bonds are developed between the ceramic grains, and this is accomplished by the densifications and the reduction of the porosity. Additional shrinkage occurs to the polycrystalline materials in addition to that which has already occurred in the drying process. The glazing is an application of the ceramic surface coating to make the piece more resistant to the water and enhance its appearance. Usual processing sequence with the glazeware are firing the piece once before the glazing and harden the body of the piece. Then apply the glaze, then fire the piece a second time to harden the glaze.